whole project was done in Houdini and rendered in Blender with cycles. I envisioned it as a quick practice run through all of the major Houdini solvers, and I'm gonna walk you through the whole project, but this will not be a standard tutorial because that would take way too long. And even like this, I tried to be as fast as possible, recorded multiple times, even cut out some more experimental node setups. But that didn't help much. Look at the length. It's almost an hour long. So if you have any questions, let me know in the comments below. So let's dive in. So here we are in Houdini, GeoNode. Everything is here. Very sloppy, but it'll do. First, we shall import the perfume for the first scene. Do some transforms to reset it to 0 position, null, VDB from polygons, so we can use it as collision. In the flip fluid DOP simulation, here is the source, another transform, let us template to see where the collision will be. This is the source, flip source, 0.001 voxel size and particle separation, so it's quite fine. Normalize cent versus position and scale. This is initial velocity for the particles, and we shall visualize it. Yeah, this is the velocity vector for each of the particles, and let's turn it off. Pop into the DOP network for flip. These were some experiments, never mind, delete them. Flip object, linked particle separation, 0 initial data, volume source, slap it in, source flip, activation for the first 2 frames, and after that we stop emitting. So we have limited amount of liquid. Boom, it's nice. And we have a nice fluid shape. Static object, flip collision. We cache it with 4 substeps for retiming purposes, because if we retime it with 1 substep and we use from speed 1 to speed 0.1, so 10 times speed reduction, without substeps we would have movement artifacts. So to avoid it, just use 4 substeps and let Houdini interpolate it very nicely. So we have something resembling Rorschach ink blots, and this is very nice. Let's pull it over here. Fluid compress. Nice. Fluid particle surface. Let it cook for a bit. Come on, man, cook. It's time to cook, man. Nice fluid. Cache it out. USD and Alembic output. I prefer USD. It has better viewport performance for Blender. Alembic is fine, but a little more stuttery when trying to work with it. Along with this, I was experimenting with the curve. I wanted to make a custom fluid along a curve, not a fluid, pop particles emission, animate the curve. We give it point velocity, different random velocities for particles while they're being emitted. Create a basic pop network with only pop drag as force. Turn off the velocity so we can see what's going on. Nice. VDB from particles, smooth, convert, clean, fuse, and we get something like this. It was nice, but not bombastic enough, so I scrapped it and went with the flip fluid one. This is the cloth VELLUM simulation. The lump of cloth out of which perfume emerges. So we give it UV. We have a sphere, scale it up, scatter, normal, and do a little bit of random normals. P-scale, set the P-scale, scale it up a bit more, and instance, give it a unique name for each piece, and instance along those points, the same circle. We remeshed it so it has a nice topology for deformation, connectivity for each piece, cloth, and we have a simulation. We have a nice simulation, and after a while the blob opens up. This is the collision object I made. It's a simple sphere, small sphere that scales up. and moves out of the cloth lump. Clears the way for the perfume to emerge. Very nice. VELLUM post-processing. Give it a bit of thickness instead of it being a single plane. And export USD. That's pretty much it for the first shot. I also played around with instancing points, ISO offset, scatter, and do a point pop with some noise, two noises, AA and turbulent noise, add them to position, and we get something like this, resembling a nebula. Give it a color. You can give it a color based on position, normals, based on age. If you're doing a pop particle simulation, you can even pop it in a flip simulation to act as a fluid without any gravity and just render out as particles or instance some stars on those particles, just making some galaxies in the background. And I wanted to keep it animated, but in order to have a manageable project scale, I decided upon just using a flat 2D plane with particles made in shader to make it super quick. And that's the first shot. Next we have, in the second shot, curtain falling down and a can being squished and flipped around with liquid pouring out. First we're gonna show what I did with the curtain. I made a group. Let us show you that group. Points, not edges, points. You have a group which is not affected by simulation. Bend it. And just after adding VELLUM constraints, play the simulation. I have it cached out so we don't need to wait. Turn off the group visualization and just let it fall down. Boop. It's nice. I did retime it a bit for it to slow down after falling down. And now it starts going slow, and exported it as USD. Next, I used NPM Solver instead of RBD and flip fluids. I still want to learn more about that solver. I think it has a lot of potential. I imported a Alembic of a random object can I found on the internet. I removed the droplets, unpacked it, match size to make it a bit bigger. Here are the UVs. Convert to VDB. Make a cut, convert to VDB. VDB SDF subtract. Make a bigger hollow up object for hollowing out the can, so it has a space for liquid. Bop. And now, after all this VDB shenanigans, we have, I'm gonna show you what, before we use npm source, we have a nice hollow object. And before that, nice hollow object. Then we use npm source for the can. Pull it back to the first frame. Come on, come on, come on, I don't want to wait. And here is the first frame. Check if it's hollow, clip. Yes, it is. Very nice. Give it a color, give it a group, so we can manipulate it and separate it after simulating. It's metal with high density, relaxed iterations, and nothing special. I did the same thing for the liquid. Scale down the basic can, VDB, it acts as liquid, set it up liquid density, another color, keep it red, group, Pepsi, and that's it. It goes straight into the solver. Solver settings are usual. I just turned off the gravity. And for the collider, I tried with the forces, but this was easier and faster. Just do it like this. Let me show you through the cache. We don't need to. Sometimes I really hate Houdini. Stop it. Yeah. We have the cached out simulation. And now it's fine. So we have two collision objects for squishing. This one is all noised up, and this one as well. So it has irregular grooves, and then it slaps the can, slap. The can hits the first object and starts flipping away into oblivion. Naturally, this goes very quickly, so I had to retime it. Let us clear this and slow it down and speed it up again. Now we need to mesh, blast the group for the liquid. So we select everything that is not Pepsi or liquid and delete it. npm surface, we got liquid, color, it's not really needed, I just use it for preview, Pepsi, and export as Alembic. I just played around with both formats. Meshing the can is a bit more involved. Here we have the can, let us remove the template for this. And the can is nice, but these triangles are way too long and these faces will not be good for deforming, so we need to remesh it. But if we remesh the whole thing, we get this. Let me show you. You see, the top gets mangled by quad remesh. No matter how you approach it, it's difficult, and it's not its fault. It's just the way it is. So I made a group from expression, which selects everything except the top, and just remeshed it locally. So we have nice topology for deformation. Boolean to hollow it out. You see it's hollow. Nice and hollow. I went overboard with this, maybe do it like this too. Yeah. Yep. Just make it clean. Scale it up by Y. And this is it. And we have nice. Let us use the almighty clip to check it. Yep, there's space for the liquid. And that's it. And this is what we have. That's it. Second shot done. Next, we shall move to the destruction of the watch. I imported the watch and I cleaned it up, deleted all the pieces I didn't need. You see there were some pieces that I don't need for my sim. Wanted to keep the central part and the mechanism. Delete everything, keep the UVs. Unpack it, give it a subdivision so it's nice and smooth. Bop. Check everything, scale it up. Yep, match size, npm source. There's an important step in this node, and I'm gonna explain why we should keep an eye on it. Yes, this remove UV, yeah. So we need to use name attribute from segmentation, because otherwise it will make it as a full mesh filled with npm particles. We need to treat it per piece. Every piece needs to have its own npm container. So if we use explode, we need to use name attribute, which we have for each of these pieces. They come with the model I downloaded, and we want to instance the particles on each piece individually. That's why I use name segmentation. Afterwards, we're gonna use the stiffness attribute and give it a bit of noise, remap it in order to visualize it, and this is what you get with the stiffness. Let us select it, E is stiffness. So before and after, it's far more irregular. Red parts are still very stiff, and the blue parts are more squishy and easier to break. They resist deformation less. In any case, I have a collision object which acts as a bullet, gave it a poly bevel for the top, animated it, so it goes whoop, npm collider, npm container, set the resolution, and cached it all out. Oh, we have to turn off this. And yeah. And you see, we have a nice simulation of bullet going through the watch and spraying the pieces all over the place. Now we need to remesh it. We need to mesh the simulation. Unpack, subdivide, nice connectivity. And I'm gonna show you what I'm doing here. We're gonna explore it a bit more. There are a couple of pieces which are very thin. They are only a surface, and they don't have normals on this side because it's only a single surface. It's not a mesh per se. This one as well. This one as well. So in order to fix it, I do thicken, and they all become meshes. Before, after. Before, after. So now they are nice and they will have clean normals once I fracture them. This is npm post fracture. And let us see how it looks. Each of the pieces is fractured nicely. Each gear, part of the mechanism, case, spring, and even the dials, even these little screws. And now we use npm deform pieces to deform the object along with the animation, simulation. And next, we just export this with an important step. There's one step missing, I forgot. I actually introduced a switch node, which keeps, you're gonna see very quickly, which keeps the object unfractured until it hits the contact point, which is I think around 22nd frame. Yes. And once we go to the 22nd frame, let it cook for a bit, it swaps to the fractured mesh. And we do this because you can see the fractures on the glass. So we just swap the meshes at the point of impact and hide the fractured mesh until it's needed. That's it. The next step is actually, I'm gonna go back here. Yeah. The next step is swapping the bullet with a wine bottle along the vines grow and all that all those things. And there we have it. Let us show the bullet. Here is the bullet. And in order to copy the transform animation from the bullet onto the wine bottle, we'll do a nice little trick. We'll match sizes of the bottle and the bullet, and we'll pack the bottle and the bullet in order for them to be represented by a single piece. You see, there's a single piece representing the bullet and single piece representing the wine bottle. Now we extract the transform from the bullet and we copy it to the wine bottle. I also rotated the wine bottle in order for the bottom side to be protruding and destroying the watch. That's done in this node. Then we have it like this. And then we export it. The next step is actually making the vines grow on the wine bottle. Where is it? Ah, yeah. This is the wine bottle. Unpack it, convert to VDB, convert, remove visualization of points, and do a quick remesh. We have a nice surface. You'll see why this is important later. But we make a group. Visualize the group. So we select, by playing around with vex, we select a group of points at the bottom of the bottle, at the bottom of the bottle. Then we make a random selection of a single point from this group, for example this, and call it a start point. Then we make another group group selection. We select just a top of the bottle and call it end, and do a random selection from this group. So we have this point and these points. Start, end. Then shortest path, and this is what we get. Let me turn off this. This is what we get. This is a nice path finding node, which finds the path from this starting point to each, as I've stated here, for each start to each end. Each start we have only one start, to each end we have a lot of ending nodes, and it finds the path to each ending node. But this is a bit linear, so I'm going to use distance from geometry, create a cost attribute, and just use it here, path costs. So we go, let me show you, from this to this. Cost attribute, I just made it, you can make it in every possible way you imagine. I made it by calculating the distance of each point from this mesh to this mesh, and I use it as cost in find shortest path node, and it skews the calculation towards this sphere, which is slightly slanted to one side, and it gives me a little bit of more organic look before, after. Then do the resample, and then we do the fuse, then we do the p-scale. It's based on height, I mean the y coordinate, and then we use the carve. Carve node just animates each curve from beginning to end, and after that we add sweep, and sweep uses the p-scale we made, so we have these roots. I added a subdivision, which is a bit heavy for this because it has a lot of points, and this is subdivided. I did this because camera approaches the vines pretty closely, so it can show the jaggedness if I don't do this. Before, after. It can be optimized further, I'm sure, but I kept it like this for now. Cached it out, match size, so it's animated along the bottle, it follows the bottle. Dynamic preview, and we have to check it out how it acts with the bottle. Let us go a little bit further. It follows the surface pretty nicely, and we export this one as well. Next, this is the shroom. The mushroom is made entirely in Houdini. It's made out of two curves, one of which is animated via KineFX. I'm gonna show you right now how it looks. Resample so it's nice and smooth. And this is how I animated it. Pop. Revolve to make a mesh out of this curve. You just revolve it to make a mesh. Group and attribute noise. Position noise, so it's a little bit jagged on the edges like real mushrooms are, and we're gonna see how it looks. Nice. Now we make a stem line, let us select it, attribute noise for the, I entered it by mistake, attribute noise, resample, orient, we need orient along curve, then we use carve, and it goes. Then we add attribute pop, so it's always moving a bit even after finishing the animation. You see it's slightly moving about, very subtly. Then we isolate the top point and instance the hat on the top point. So when the curve grows, the hat follows mushroom hat. It's not a hat, but it looks like a hat to me. It follows the orientation of the curve. It's nice and smooth. Once we merge them, we get this stem and a hat, sweep for the curve of the stem. It's a bit rough, subdivided, it's super nice. merge them, we have groups for each piece, so it's easier to assign materials. I purposefully skipped this part here because it's a mask which pertains to that deformation that follows nuclear blast, that wave that actually lifts the surface and deforms the geometry of the mushroom. So I made a little bit of a mask, and it's stored in an attribute called bulge. I'm going to show you how it looks like. The bulge. So yeah, this is the bulge. It's all in this single vex node. You can ignore the bias and the cross product of vectors. I was adapting it for another thing I was working on. And then we add some attribute blur. And look at it. Yeah, very nice and smooth. And down the stream, I made a node, which is a single line vex node which actually does the deformation. You lift each point, which is affected by the bulge mask. You deform it along the normal vector, and you can change the scale of deformation here. I kept it at a fairly low value because I want it to be nice and smooth, but you can go crazy and do whatever you want with it. Yeah. And that's it. That's the whole geo deformation I had. This is a null with a parameter which I used to actually animate the speed of the wave in this node. But I was too lazy to, while I was dialing in the speed of the wave and the whole deformation, I didn't want to do this and then do this. I just pasted this parameter with relative references, and that's it. It was animated, exported and sent straight to Blender. And final piece, well, it's not a final. This slash shot is very long with multiple elements. So this is the nuke part. I'm gonna go straight to the bottom and show you the result. It's made out of two pieces, the nuke explosion and blast rings. Let us see where it is, like this. This is the nuke, and these are the blast rings. Yeah, nuke, and I'm showing only the smoke here, visualizing the smoke due to the speed. We don't need to play with the shaders in Houdini. Blast rings and nuke. For the nuke, I just took the mushroom top, isolated part of the surface, scattered a couple of points. Let me show you. These are the points. 5 points. Randomized start frame attribute. PYRO burst source. Let us calm it down, put it down, yeah. And here is the burst. Yeah, it's nice. Pop. And that's it. I played with the settings in the burst. This node is absolutely great for kit bashing and experimenting with different kinds of explosions. It's far better than the earlier versions of Houdini and easier to work with. Then you go with volume rasterized attributes, and I created a VDB from the same surface of the mushroom in order to use it as collision for the PYRO solver. I cached it out, and I'm gonna visualize it here. Yeah. And here's the nuke and the flames. More difficult part was actually tackling the blast rings. I made 2 circles here, 2 circles, and blasted the middle part, so we have a nice ring. Poly extrude and do a copy. I made 3 copies, and from 0 to 3, and this node keeps scaling them so they appear, bop, 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 and they keep growing slowly. Add a bit of divergence, PYRO source, remove the point visualization. I added some attribute noise, so it's nice and swirly. And it gives a nice texture to the blast strings. Of course, you can use, in PYRO burst source, there's a preset for blast strings, but it was difficult for me to control, so I made my own. And I like the look of my own far more than the integrated one. This is a PYRO solver, PYRO post process, and we just cached it out. I hate this. And here is the final product. Let us look at it again. I almost forgot. In the PYRO solver, I'm gonna turn off the simulation update. I just want to show you the values. I animated the timescale for the nuke, so it's pretty fast, 2 times the speed, and then it stops and goes back to 0.5. So quick blast, and then it slowly starts propagating up. Very nice. I did some adjustments to dissipation. I lowered it significantly because I didn't want the smoke to disappear, because when I was looking at reference material for the nuke explodes and the whole mushroom cloud lingers a lot. It's not like with smaller explosions, poof, and it quickly clears. There's a lot of debris and whatnot, so this is a very small value for dissipation. And for the shape, I used fairly high disturbance and a small turbulence value. And for the other solver, I used small disturbance, small turbulence, buoyancy scale was almost unchanged, and a slightly higher dissipation rate. But these values are not set in stone. You gotta explore you just need to know what each of these values does, and explore and try to slide your way into the look you are aiming for. And last but not least is this cancerous piece over here. Planet being crumbled and destroyed and sucked into a black hole. This seemed like, before I started working on it, like it was going to be the easiest part of the whole project. It was not. Indeed, it was not. I made a moon, a simple sphere. Let us see, where is it? Yeah. A moon, normal, UV, BAP. Show the UVs. Yeah. It's polar projection, subdivision, and then I used RBD material fracture, but with input points. I used this chunk, this is the main planet, and this little chunk I used to scatter points. So I scattered 200 points and used them as input points in RBD material fracture node in order for the fracture to be localized. I wanted more detailed fracturing at the place that's planning to destroy, and the other part of the planet I was fine with it having big, less interesting chunks because they were not gonna show up in the simulation. Just saving up on render and file caching time. And let us see, this is what we get. Let us use exploded view. So you see, the input points I used were heavily propagated here, and the back side of the planet has less interesting, bigger pieces, which is fine. So yeah, this whole tree I'm gonna skip clicking on it, but I'm gonna show you what it does. It is dedicated to inside UV unwrapping, because when you use RBD material fracture node, it's super nice, and it tries its best to do UV both for outside and inside groups, but this is what it looks like when you do the inside group. Uniform scale. No, this is constraints. Outside UV is nice. Inside, stretched out, all messed up. So we're gonna do this. We're gonna blast all the outside faces. We're going to use UV auto seam and export seams group name, UV flatten. So from here, we go to here, obvious difference, but we're not done yet. UV layout, and now I'm going to show you the difference. We can turn off the blast group, and we can scale it down a bit. There's no need to exploit it that much. All of the faces are nice and clean, and before unwrapping, a big mess. After unwrapping, very nice. That's the same thing I did here. I just don't want to wait for it to cook again because there's a lot of pieces and it takes a lot of time. The thing that actually bothered me a lot while working on this was, why is there a need to cache anything? Ah, Jesus. Okay, we're back. I sorted that thing out. This is the cached out simulation with UVs and everything. And I'm going to explain how I achieved this deformation with forces only. I used glue constraints and no impact. So how did I break them? Well, I started with all points set to inactive, or active value was set to 0. So they are all practically not a part of the simulation. And in order to activate them and procedurally delete the constraints, so the forces which are used in the solver can be used to pull out and rip out the pieces, I did this. I added a single point. Let me show you. There is the point. Where is it? Come on. There it is. There's the little point. Retime. And we have... And I added a sphere to visualize the effect. So if a distance between this point and each of the points on the constraint geometry is smaller than a threshold, it deletes the constraint geometry and simultaneously activates the piece within this radius. So this is what happens. You can see that the constraints are being deleted dynamically. Up. And each constraint deleted means that that piece is free to be influenced by the force. And also, each of these pieces are being activated. And basically that's the principle. I'm going to show you the wrangles within the solver, which enabled this. This is the curve I used. Let us use this. Turn off the point visualization and let us template the curve force. So this is the force that influences these particles which are being released. And we are going to go to the frame number 1, so we avoid needless cooking. Pop into the RBD solver. So this is what we are doing. I'm checking if the distance between the positions of the geometry of each point and the external point I showed you is below a certain threshold. If it is, the piece becomes active. The second node does the same comparison, but removes the point. But it works on constraint geometry. So it dynamically deletes constraints and enables them to practically escape the planet and be affected by the force. And the force is pop curve force with generic settings, nothing special. I just use SOP curve so they can move along that curve and being sucked away. And you see they slowly go up and straight into the black hole. There was another thing to solve, and that's, I wanted that, let's go back to this. I wanted as they go away further from the planet and closer to the black hole to be scaled down and ultimately disappear, simulating they are being sucked into the black hole and being disintegrated. So to do that, I extrapolated simulation points from the sim, file cached, everything, set some basic p-scale for each point, made an arbitrary group. I'm going to show you the group now. No, it's a point group. So after the points are away from the planet, this is a changeable, a variable threshold. I can do this, I can do this. I let it be 1.5. So it creates a group, and I called it group scale. And within a custom SOP solver, we are doing this. For if the point is in the group called scale, we scale it down by 1% every frame. So this is the effect. They start scaling down, scaling down, scaling down. Once they cross a certain threshold, they are all scaled down. They are all scaled down by 1% procedurally. That's the beauty of the SOP solvers. And it's only a couple of lines of code. Before SOP solver, after. And after that, I used unpack, attribute delete, name from groups, group delete, and that's it. Name from groups, I made two name attributes for inside and outside, inside, outside. So I have nice and clean normals. What do I mean by this? Well, I'm gonna do a double export, and I'm gonna show you in Blender after we finish the talk in Houdini why I did this. Name from groups, delete the attributes, so we export it as a single mesh without any name attributes, and you'll see what happens. We'll leave it for later. There's one more thing to explain, and that's the smoke coming from the crumbling planet. We are basically doing this debris source, which is emitting particles depending on the factors, on the parameters you use here. I used distance threshold, set a custom lifespan to be a little bit longer, and as they separate from the planet, they emit particles. I used trail, and I added a bit of attribute noise, just a little bit, so they swirl around. And this is basically how it all looks after a basic PYRO solver. Let us PYRO. And this is it. Very nice. They break away from the planet and leave a swirling path behind them before they reach their ultimate fate. And lo and behold, it is done. This was exhausting, and I hope it holds some value to you. Now let's go into Blender, and I'm gonna show you what I meant by this particular way of exporting name from groups, separating to inside and outside, and you'll see exactly what I mean. Here we are in Blender, and this is the problem I was talking about when exporting fractured objects from Houdini into Blender. This is the method where you separate it to inside, outside, and inside group. So you basically have two objects, even though you separate the faces. And this is the part where you just delete the name attribute, and you get this jumbled mess. When you shade flat, there is no issue with the normals. When you use shade smooth, it goes to hell. Shade auto smooth, it gets a little bit better, but even when changing the cusp angle, it's simply unfeasible. And this works right off the bat. You click on the inside group, auto smooth, and it's exactly like you saw it in Houdini. And it's easy to actually assign materials. You click on the outside, you do something like so. Unfortunately, my method, which I stumbled upon completely randomly, is efficient. Now let's go back. Let's open the project I used for rendering the Houdini stuff. Here we are. You can see the deformation. We're just gonna move out. Here is the watch being absolutely pummeled by the wine bottle. I always make that mistake. Nice. There we have a big black hole with its event horizon, and once we move here, it's gonna take a while, and there it is. Planet and debris going straight into the black hole, everything working as intended. There's the npm simmed can with its liquid, the watch. I mean, you can always do better, but I have things to attend to, so I had to cut my losses at a certain point and accept the quality, the level of quality that I achieved here. And that's it. One of the few things I'd like to mention, maybe the most important thing, is scripting. For example, when I used the original watch to transfer the materials from that one to the one that I fractured in Houdini, I used, I think, yeah, it's this script. I'm not gonna bother you with programming if you don't like it, but it's using Python and it's scanning for the same names of the meshes and reassigning the material from the active mesh. Let me check. Target empty, context active, source empty. So you have a source to the target, and it is transferring the materials from the source to the target by matching the names of each mesh. And it's even finding the suffixes, which is 0.001, whatever, and cleaning them and assigning successively each material, so you don't have to go through 60 or so pieces of this watch, of their gears, dials, knobs, bits and bobs. It just does it for you. So what I'm trying to convey is the Houdini is not the only place where you can use proceduralism or programming. Blender is very open for Python, and it can lessen the load for you. Even if you don't want to actually dive into programming, you could use AI to give you some vibe coding material, and most of the time it does a good job. This was generated by AI in 5 or so seconds. I've written also my own scripts because I do C, C++, Python programming, and I find it to be fun. But everybody can do this, and you should. This is what computers are for. Automate your business, your workflow. Abuse the AI, they are our slaves. Oh, I forgot about one thing. The black hole wasn't made in Houdini, it was made in Blender. I made my own, but I used this. This was a finished asset that I downloaded, and I used it in my project because it was nicer than what I made. It has, I'm going to show you right now, it has a layered disk, which has an insanely nice effect. I managed to do this sphere procedurally. It's kind of easy, but these multiple disks give it a bit of depth that I like. You can do it by programming in Vex, and there is a nice Reddit post on it, but it's more difficult and time consuming than this, so I picked Blender for this element. And that would be it. Have a nice day. See you next time.